We're now talking about subtracting rational expressions. So we're looking at this example, 2x squared minus 30 over x squared minus 7 minus x plus 5 over x plus 3. So the step process for subtracting rational expressions is the same, but this example is going to throw a little bit of a twist into the mix here. The reason why is if we look at the numerator of our first or our second fraction, it's an expression as well. So same thing with our numerator of our first fraction. So step process, as we said, is still the same. We have to be careful of two things, the subtraction and the expression. So step one is still the same step. We're going to start by finding the LCD. We're going to find that LCD by factoring. Our first denominator, x squared minus 9, that's going to factor to the x minus 3, x plus 3. Our second fraction denominator is already x plus 3. It's not going to factor any further. So in this example, our LCD is going to be that x plus 3, x minus 3. Step 2 is the equivalent step. So we are going to make each fraction equivalent to that LCD. So our first fraction, if we look, already has that common denominator, so that's good to go. Our second fraction only has the expression x plus 3. It's missing the x minus 3. So what I'm going to do is I'm going to multiply both the numerator and the denominator by x minus 3 to make it equivalent. Now, our third step is to simplify, but we're going to simplify the numerator. Now, this is where it gets a little bit tricky because we're taking an expression multiplied by an expression, and we also need to keep in mind that we're subtracting that. So what I'm going to do in this example is I'm going to rewrite this as all one big fraction. So that's going to give me the first numerator, 2x squared minus 30, minus the quantity of x plus 5 times the quantity of x minus 3, all over our LCD. Now from here, if we look at simplifying just in the numerator, we have this binomial times this binomial that, yes, we are going to have to FOIL. So I'm just going to do a little bit of foiling work up here. So if I were to FOIL, that is going to give me x squared minus 3x plus 5x minus 15. Now remember, foiling is just simply your first, outers, inners, and last. Now the big thing to remember is that this is all still technically being subtracted. What I'm going to do is I'm going to combine like terms and just simply rewrite this. So I still have this first fraction here, this 2x squared minus 30, minus the quantity of x squared, if I combine those two middle terms, plus 2x minus 15, all over the LCD. So we're closer to being simplified in the numerator, but we still need to represent the subtraction. So what we now need to do is we're going to take that negative sign and distribute it. So this 2x squared minus 30 is going to stay the same. My second expression is going to become negative x squared minus 2x plus 15, still all over that common denominator. From here, we're still working to simplify. We're going to combine our like terms. Bring this all the way down here. So first two like terms, 2x squared minus x squared. That's going to give me a positive x squared. I then have our middle term, negative 2x, doesn't have any like terms to combine with. And then if I combine my last two like terms here, I'm going to get a negative 15. This is all over my LCD still. So that's the hard part of this example, seeing the foiling as well as seeing the distribution of that negative sign. From there, flows a little bit nicer. Our final step, let's sweep this in here, is we're going to look to simplify the fraction. The way that we're going to do that is we're going to look to see if the numerator of our fraction can factor. So in this example, x squared minus 2x minus 15 can factor. That's going to factor to x minus 5, x plus 3, still all over a common denominator, x minus 3, x plus 3. If we now look, we have an x plus 3 in our numerator, canceling with the x plus 3 in our denominator, and then that would just leave us with the x minus 5 over the x minus 3. So a little bit more work, but the big thing is just the patience of working through each of these steps.